Going to be doing today is on this video is teaching you how to factor quadratics and how to use the zero product property to solve quadratic equations that are equal to zero. So for example, an example problem where both these skills of factoring and using the zero product property would be a problem like such. 12x squared minus 39x plus 9 is equal to 0. I'm going to show one method on how to factor quadratics. There's many methods out there, but this one I just recently found and I kind of like it. It's really quick, so I'm going to show you that method now. First thing to use the method I'm going to show you is you got to look at the coefficients of the quadratic 12, negative 39, and 9. As long as the quadratic's written in decreasing order, where the highest term with the biggest exponent is in front and the constants at the back, and they go in decreasing order. So quadratics in a trinomial, the x squared is first, the term with an x is in the middle, and 9 is at the end. What you want to do is make sure there's no greatest common factor between those coefficients. You have to do this first. If you don't, this method doesn't work. So looking at 12, negative 39, and 9, I know that 3 is a common factor of all of them. 3 goes into 12 4 times, and 3 goes into 39 13 times, and 3 goes into 9 3 times, and I have this still equal to 0. Now we factored out the 3. Remember this 3 out here, but we're going to really concentrate on what's inside the parentheses. 4x squared minus 3x plus 3. The method I'm going to show you, you make what I call a diamond. It looks like an X, but I call it a diamond for some reason. 4 times 3, you go the first term times the constant, the coefficient of the first term times the constant. 4x times 3, well, that's 12. Make the middle term, or the coefficient for the middle term, negative 13, put in the bottom. And what you're looking for is to fill in the sides. Two numbers that multiply to 12 but add to negative 13, well, negative 12 minus 1 would add to the negative 13, and negative 12 times negative 1 would be a positive 12. So that works. Next thing you do, make two little fraction bars and look at the first term, 4x squared, put a 4x. Take away the square, put just 4x on the top of both these fractions. Then place the sides of your diamond on the bottom, negative 12, negative 1. And think of this like a fraction. How many times can you want to reduce the fraction 4 over negative 12? 4 goes into 4 one time. 4 goes into negative 12, well, negative 3 times. And this is what happens. Make sure you bring this 3 down here. Keep it there. But we're going to fill in these parentheses here. It has still equal to 0. 1x minus 3, or x minus 3. 4x minus 1. Now that works. What you could do is redistribute the 3 and then distribute this binomial into this binomial, or use FOIL, and it will come back to this quadratic up here. But we basically changed the quadratic from standard form to intercept form. And from this form we can easily identify where this parabola will cross the x-axis, or the graph of this quadratic crosses the x-axis. What we're going to do is use the zero product property, ZPP. We have basically 3 quantities being multiplied together to equal 0. Well, if 3 quantities are multiplied to equal 0, one of these has to be equal to 0, 2 of them, any 2 of them, or all 3 of them. So by ZPP, you have to say 3 is equal to 0, x minus 3 is equal to 0, and 4x minus 1 is equal to 0. All 3 of those. Well, the first one's pretty obvious. 3 equals 0, that's not true, so we can just go ahead and cross that out. That's not where our zeros are. But our zeros can lie in here. These two numbers or quantities in there, x minus 3 and 4x minus 1. Let's figure out what x is that makes these equal to 0. What you do is add 3 to both sides. X is equal to 3. So add 1 to both sides for the last one. Divide by 4, and you get x is equal to 1/4. Okay. what this is telling me are these are the x values that if I substitute them into the quadratic, it will produce a 0. So these are the solutions to this quadratic. Also, these are the x-intercepts. This is, or those aren't the x, is it? Yes, 3, 0, and 1/4, 0. Okay, just like that. Okay.